In this question, we've given the sum of the first 5 terms of an AP. We're told the sum is 20. We're now told the 8th term is 19. Firstly, what we need to do, we don't know anything about the value of the first term or the common difference, so we need to use all this data to work that out. We can put a few things into place. We know that 20, which is the sum of the first 5 terms, was equal to n on 2 lots of A, plus n minus 1, which would be 5 minus 1, times D. So we get the 4D. We've got an equation with A and D in there for that one. We also know that the 8th term is 19, so A plus, again, n minus 1, so 8 minus 1 times D will give us a second equation. So 19 equals A plus 7D. 4 from this part is equal to A plus 2D. We've got simultaneous equations, and it's not a bad simultaneous equation because they've both got A there. We do the subtraction of equation 2 minus equation 1. A's would cancel. 19 minus 4 gives us 15. 7D minus 2D gives us 5D. So that leaves us with D being equal to 3. And if we take D being equal to 3 and sub it back into this equation here, we'll get A being equal to minus 2. So we found the values of A and D. That allows us to go and do the second part of the question, which is to find the sum of the first 50 terms of the series, because we know A is minus 2, D is 3, and N is 50. So we're able to substitute into that equation and then do the calculation to give us that answer. Question 6 is a little bit trickier. The sum of the first 20 terms is 138. The sum of the first 19 terms is 125. Find the 20th term of the series. Now, it does seem a little bit difficult at times until you start to work it out. If I use this example, the sum of the first 3 terms here would be T1, T2 plus T3, where the sum of the first 4 terms is T1, T2, T3, T4. The difference between the sum of the first 4 terms and the sum of the first 3 terms is just this 4th term. So all we need to do is we need to add that one on to this amount to get the sum of the first 4 terms. So that's why we're getting this idea. The sum of the first 19 terms plus the 20th term is equal to the sum of the first 20 terms. So I can say the 20th term is the sum of the first 20 minus the sum of the first 19. We've got those values. The sum of the first 20 is 138. The sum of the first 19 is 125. So we can do that substitution. The 20th term must be 13. It is a little bit hard when we just read in the question, but once we start putting in the numbers and understand the relationship between the 3 values there, then it works out okay. In the last question here, question 7, we want to show that any term is the difference between the sum to n terms and the sum of S of n minus 1 terms, so the sum of the number of terms before. Basically, we're showing the general way of question 6. So the idea, if we take the nth term to be the sum of the first n terms, so we just applied the formula, and the sum of the first n minus 1 term. So instead of having n, we've got n minus 1 in there. But again, we've applied the formula for the sum of n terms. And then it's just a lot of algebra, and it's a little bit tricky algebra. So you're doing the multiplication of the brackets out. So the n on 2 times 2 gives us just na. That's n minus 1 times d, so the d multiplies out those in there first to give you, and then expand multiplied by n on 2 to give you those terms. Then minus n minus 1 on 2 multiplies by 2a. And then the same thing multiplies by n minus 2 times d. And we've cleaned up that a little bit there and made it a little bit simpler to try and expand out. So when we start multiplying every term here by every term here to get the terms out there. And then once we've got to that point of expanding that to get down to that point, then we want to do is start to collect like terms. So na cancels with an na. A half n squared d cancels with a half n squared d. And we see how all the cancellations go down until we come down to nd plus a minus d, which we can factorise the d out to give us a plus n minus 1d. There's the proof of that formula for Tn via this method. Not an easy thing to do because there's lots of algebra, lots of places to go wrong. but you just got to, you can see why that would give us the nth term through all that expansion and collection of like terms. So you've got to take a lot of care.